So this is the app that I like to use. It works well for Android and it also works well for iPhone. So this app is Foreign, registered trademark. I have no affiliation with this company whatsoever. I just like their app. So we're going to open this up. And if we open it up, it may have some questions for you to answer, marketing, whatever. But if you see, it has a whole list of refrigerants on this app. So there's tons of refrigerants out there, and there's way more than what's listed here. They're just putting in here the most common refrigerants. So we're going to start off with Foreign, which is their brand name, but it's really R22. I want you to learn this as an HCFC 22. So we're going to click on that one first. Now if we pull up this app, it gives us tons of information about this refrigerant. At the very, very, very bottom, it says it has a global warming potential of 1,760 times greater than CO2 and an ozone depletion potential of 0.055. It has our classification safety group as well as a bunch of other information. Let's look over here at the very top of it and we see where it says PT chart. We're going to click on that next. And now this is really nice because it pulls up a temperature pressure chart. Very simple. It just has the pressure on the right side and the temperature on the left side. But if we look on this, we want to make sure that we're in our correct ratings. And if the top right hand side it says BARA, we want to scroll through and there's PSI gauge. That's what we want, PSIG. It also has PSI atmospheric, and bar A, and PSIG. So we want to make sure at PSIG, we want to make sure the centers for degrees Fahrenheit. If you're in the US, anywhere else, you can actually convert that to Celsius. This video we're going to use Fahrenheit, and we're at sea level. But if we were in high altitude, we can adjust that as well. We're going to leave this at sea level, PSIG, and Fahrenheit. So we're going to start off with just some examples. Let's say I had a 40-degree evaporator coil. So we're going to raise the temperature until we get to 40 degrees Fahrenheit. So I'm going to put it at the top of the screen, 40 degrees Fahrenheit. That means our pressure would be at 68.6, or we'd round that to 69. So 69 psi on the suction gauge would mean you'd have an evaporator temperature of about 40 degrees Fahrenheit. As your pressure went up, let's raise the pressure to say 81, my evaporator temperature would be boiling at 48 degrees. I have a 48 degree saturated temperature. On our condensing unit, let's say our outside condensing coil, let's say our head pressure was 196 psi gauge, our saturated temperature would be 100 degrees Fahrenheit. And we could go on and on and on to this list, but it's just got tons and tons of great information for us to use. Now, what's even better than that is it gives us some other options. We're going to click right next where it said PT chart, we're going to click on PT calculator. So this is really cool. Let's say that I want to find out my liquid pressure. I already know that. It's on my gauge set. I'm going to put in here 250 psi. I'm going to hit the apply button, and it gives me a saturated temperature, a condensing temperature of 117 degrees Fahrenheit. We can change this number as many times as we want. Let's say that we'll say we have 40 psi, apply. That means my saturated temperature would be at 17. That would be below freezing. It would be frosting up. Let's say I wanted to see what 32 would be, 32 degrees Fahrenheit. I'm going to put the Fahrenheit first and apply. That tells me that my suction pressure, I never want it to be below, we're going to round this to 60 psi because I'm going to be at freezing. So it's a nice quick way of doing it. Let's go back. We're going to hit the back button, and let's go to another very popular refrigerant, which is 410A. Now notice these are many color codes. Now they're going to make all the refrigerants gray because the color codes throw people off. But 410A is here. We'll put it at the top of the screen. That's HFC, hydrofluorocarbon 410A. Now it's very important not to get this mixed up with other refrigerants such as 401A. So I have students many times will have the wrong numbers because they're at the wrong refrigerant. So we want to make sure we're at 410A. 410A, we're going to click on this. It gives us all the properties. It has 0 ozone depletion potential at the bottom, and it has a global warming potential of 1,924 times greater than CO2. At the top, we're going to click on PT chart, and it's going to give us the same chart we have all the way down in this whole system. But notice now we have a liquid pressure and a vapor pressure. Any 400 series refrigerant, in this example 410A, any number with 400 in it, you have a different vapor and liquid pressure. Now 410A is so close, you can see the liquid pressure 5 to 4.9, it's so close there's no difference essentially in it, but because it's a 400 series they have to give you that option. We'll look now, I have an example of 549.3 and 548.3. There's 1 psi difference in that. You're not going to be able to see that difference, 41 degree temperature. So it's a really cool way to find your temperature pressure. And we also have this very same option, PT calculator. So we can put our temperature in here, let's say 32 degrees. I'm going to apply. That means my pressure, if it's on the high side, it would be 101.4, and on the low side, 101.1. Notice it's really the same number. They're so close together. So I want to make sure that my suction pressure was above 101 to make sure I'm above 32 degrees. We'll do this number again. Let's say I wanted to have a 40 degree evaporator, and by note, I want to make sure there is no 40 degree evaporator, but just as an example, we hit apply, 40 degree evaporator, apply. That means our vapor pressure should be at 118 psi gauge. Let's say my outdoor pressure was at, let's say 450. We'll just pick a random number. That means that my liquid condensing temperature would be at 125.5 degrees Fahrenheit. It's a really cool app. It's a quick way of getting, if you have an analog gauge set, to get the numbers, but still that analog gauge set isn't going to be so accurate. This also does something for superheat and subcooling. We're not going to use this. I don't like how this app uses superheat and subcooling, and we haven't talked about that yet, so we're going to save that. So it's a really great little app. We go back, it's got tons of different refrigerants in here. We can pick R600A. Well, notice R600A has a global warming potential of 0. There's 0 climate change with this. Ozone depletion of 0, but it's a safety classification of A3, which means it's flammable. R600A is isobutane, and even says highly flammable refrigerants, and replaces R12 and 134A. So tons of information in this app. It's just fun to look at different refrigerants, tons of information for those refrigerants, and it's a great tool to have. It takes up very small space in your phone, and it's great for going through and answering questions in your book. Now, don't let that take away from your ability to use a temperature pressure chart for the exams. Not just the EPA exam, but many other exams you'll take in the future will require to convert temperature to pressure. But these apps are super handy and really speed things up.